Students, this is lesson U3A04A. By the end of the lesson, you should be able to say, I can identify congruent right triangles. So this lesson is very, very specific as to identifying why triangles are congruent. And why am I saying it's specific? It's because this the technique that we're going to show triangles are congruent are only unique to right triangles. Okay, so what we're about to talk about in this lesson is only applicable to right triangles. So let's take a look. All right, so if you recognize that what you're dealing with in a particular problem or in a particular proof is in fact a right triangle, then what will happen is you can say that two right triangles are congruent if you have the following situation. So notice right now, I have the acronym H and L. In a right triangle, which sides starts with the letter H? If you're thinking of the word hypotenuse, then you're absolutely right. And then the other two sides of the right triangle are called legs. So in a right triangle, if you have a hypotenuse, if you have two right triangles, I should say, and if you know the corresponding hypotenuses are actually congruent, and you know you have a pair of congruent legs congruent, then you can conclude that both triangles are actually congruent based on hypotenuse leg. So you may be wondering, like, why or how is this even possible? This is actually based off of the Pythagorean theorem. So if you think about it, if you are a fluent user of the Pythagorean theorem, right? The Pythagorean theorem has something like this. So let's say if I have a triangle, a right triangle, and both right triangles have these two sides, okay, have a hypotenuse, which is 5, and a leg, which is 3. Guess what both triangles will have as their third side, right? The third side between both right triangles will be identical. It must be 4, okay? So again, hypotenuse leg is appropriate only for right triangles. So if I take a look at this next situation, and again, this is directly related to hypotenuse leg. I'm just using trying to demonstrate this. This is also applicable if we're talking about the other pair of legs. So if you have one leg congruent, corresponding legs congruent, and one pair of hypotenuses are congruent, then again, you can say that the two triangles are congruent. If you have two legs congruent in a right triangle, then we call this SAS, or you may call it leg-leg. Either way is fine. Excuse me. All right. And then similarly, okay, if you have in a right triangle, if you have another angle and a leg are congruent, you can call this angle leg, or this is just basically angle side. Or you can have two angles congruent, okay, and the hypotenuse, corresponding hypotenuse is congruent. You can call this angle hypotenuse, or it's really just angle side then, okay? So really the main takeaway, okay, is there are these two theorems. It's this situation here that's new, okay? Hypotenuse leg. The others, okay, are just variations of side, angle side, angle side, and so forth. Okay, so let's take a look at our first example. The first example we have here, I encourage you to pause the video, and again, just to list out all the different sides and angles that are the same, and then from there, what we are going to do is we're going to list out all the sides that should be congruent because the two triangles are congruent. Go ahead, pause the video. After having thought through this, okay, you should have written down that all the givens, okay, which are angle H and angle U, are right angles. You also know that HT is congruent to US and that AT is congruent to NS. Okay, so wait a minute. There is a declaration in this proof that we have right angles, thereby making both triangles right triangles. All right, so that's a step in the right direction for us to use hypotenuse leg. But wait a minute, we also recognize that HT and US, that's a leg, and AT and NS, that's a hypotenuse. Look, we have enough information to say hypotenuse leg. Both triangle HAT and SUN are right triangles. So triangle HAT is congruent to UNS. And the reason for this is because of hypotenuse leg. Okay, so what other things can we say are going to be congruent as a result of these two triangles being congruent? We know that all the other sides and angles, okay, so angle HAT must be congruent to angle UNS, angle ATH must be congruent to NSU, and angle side HA must be congruent to side UN. All right, let's take a look at another example. Pause the video, okay, and see if you can figure out what other sides and angles are going to be congruent as a result of the two triangles that are being congruent. List out all the givens. So having thought through this, let's take a look at it now. So looking at the set of givens here, it is established that angle D and angle B are both right angles. That is important in the declaration that these are right triangles. We know that AD is congruent to BC because it's stated in the problem. Okay, so we do not have hypotenuse leg at the moment. We do have a leg and we do have a right angle, but we don't have a hypotenuse. Can you see where the hypotenuse is and why the hypotenuse is congruent in both triangles? If you're saying that AC is congruent to AC, then you're absolutely right. AC is in fact congruent to AC, and it is being shared between both triangles. This is true because of the reflexive property. So because we now have a hypotenuse and a leg, and this is in fact a right triangle, we now can say that the two triangles are going to be congruent. We can say that triangle ABC is congruent to triangle CDA. And this is true because of hypotenuse leg. So, as a result of these two triangles being congruent, we can then therefore declare all the corresponding parts of the congruent triangles congruent. So let's take a look. We know that side length AB must be congruent to side length CD. We know that angle CAD must therefore be congruent to ACB, and ACD must be congruent to CAB. Yeah. Let's take a look at another example, and I'm going to fast forward here to slide number 51. I'm just going to fast forward here just to give you some variation on different types of problems that you may encounter. So let's take a look at this guy right here. So here you're told that AB is perpendicular to BC, CD is perpendicular to AD, and that AB is congruent to BC. Let's write all this information down on the in the proof. All right, so actually I went a little ahead of myself. There's actually only two sets of givens here. So again, AB is perpendicular to BC, and CD is perpendicular to AD, and this is a given. We also know that AB is congruent to BC, and that's a given. So notice right now, okay, that this setup right now, in question number 5, okay, it is not clear that the two triangles are right triangles. There's no statement that's declaring that we have a right angle here. Which is why, for statement number 3, okay, looking at this, I immediately can tell that angle B and angle D are right angles. So these are right angles. And why are they right angles? Well, that's because perpendicular form right angles. So perpendicular form right angles. Perpendiculars form right angles. So now that we know that the perpendicular form right angle, we can now safely declare that these two triangles are in fact right triangles. Okay, so now knowing this, okay, we have AB is congruent to BC. That is a leg, but we also recognize that AC is congruent to AC, and that is because these are it's a side that's being shared between both triangles. But also recognizing that AC congruent to AC, this is actually a hypotenuse. So now I have a hypotenuse, a leg, and this is in fact a right triangle. This is enough for me to declare that I have BC, or actually, I can say that triangle BAC is congruent to triangle DCA, and that is because of hypotenuse leg. I can then therefore declare that BC is congruent to DA because of CPCTC. And that's it.